Here we are on the surface of Earth. We're just out here in the grass. I look up, it's a nice sunny day. You can see the sun right here. But what if the sun was bigger? Like, a lot bigger. That is what we're gonna be doing today. Oh wow, the ground is so bright. We're gonna be replacing the sun with different stars to see what that looks like and also what kind of effect that's gonna have on the solar system. Look at the surface of Earth, dude. Completely burning right now. So the star we have replaced it with right now, this is Rigel, which is part of the Orion constellation. You can see just how large that star is. Almost going all the way out to the orbit of Mercury here. It's Mercury, right? Yeah. That's how large it is. If this were to actually happen, all the planets would get sucked in. We're going to be showing that too in Universe Sandbox. So we're going to be using Space Engine to kind of get the visuals of what this might look like. Like, crazy system. This is the solar system. But now we're going to go to Universe Sandbox and replace the sun too to see like temperatures and what happens to the orbits. So here's a normal solar system. This is our solar system. But what we did in Space Engine, we replaced the sun with Rigel. So we can do that here by going replace and then just typing Rigel and replace. So you can see it looks similar. Space Engine has the better graphics, but the actual simulation works perfectly in Universe Sandbox. So let's just watch. If this were to randomly happen, what would happen to Earth? Let's slow down the time. So immediately it's going to start heating up. You can see that super fast. And that is actually not going to be the worst of our problems, because just after a little while, oh, you can see everything's glowing. I mean, you'd probably burn before you got sucked into the star, but Rigel's mass is a lot more massive than the sun. So it's just going to immediately suck all of the planets in, and we can slowly watch as the whole solar system gets sucked into Rigel. The outer planets, it looks like Neptune and Uranus are still alive, but they have highly elliptical orbits. They swung around the star. You can see it's very bad. That's what we're doing today. We're going to do another couple stars that are actually even bigger than Rigel. Rigel is the smallest star we're dealing with today. Next up, we're going to do Betelgeuse, which is probably my favorite star. Very large. You'll see how big it is in just a second. Here's the solar system. You can see the orbit lines of the planets with Betelgeuse at the center. And you might be like, oh, that doesn't look that much bigger, until you realize that this planet right here, the closest one to the star, is not Mercury, that's Jupiter. Every single planet closer to the sun than Jupiter is inside of the star right now. And we can actually fly in the star because it doesn't have the physics like Universe Sandbox. So all of the stuff is still like inside of the star. So there's Earth, right? And the sun's still here too. But you can see all of that is inside of Betelgeuse, a extremely large star. Very scary. Let's see what kind of effect this has on the entire system if we just plop it in. Okay, so back in the solar system, before I just replace it, I want to show you the size of it. So for reference, there's the sun, right? That's how big the sun is. And the sun is absolutely massive. Like, for a quick comparison, just to show you how massive the stars are that we're talking about, here's the sun next to Earth. I just plopped Earth in here. Look how much bigger the sun is than Earth, okay? But now, the sun compared to Betelgeuse is insane. This shadow here is the size of Betelgeuse, and that's the solar system. So now let's actually replace the sun with Betelgeuse. Wow, okay. Absolutely insane how big these stars are. So all of this stuff in here is about to get obliterated as soon as I press play. Let's slow down the time. Okay, all of that disappears. I wonder if anything survives this time. We had a couple planets survive last time. Jupiter goes in. So big. I don't think anything's gonna survive. Oh, there's like massive explosions on the surface. Is that what that is? It must be, right? Everything getting absorbed by Betelgeuse. Look at that. That's crazy. Okay, it looks like we might have a couple asteroids. Is it just Sedna? Sedna is the only thing to survive. Oh, and we have this little asteroid here. So Sedna's a dwarf planet, and it already has such an elliptical orbit that that's what saved it here. If Betelgeuse replaces the sun, everything dies, except Sedna, I guess. Have you guys ever been in public and you notice there's a free Wi-Fi available? Well, did you know that connecting to public networks like this can expose your data to hackers? The hackers will not be able to get your data, however, if you use today's sponsor, Surfshark VPN. A VPN, or a virtual private network, creates a secure tunnel between your device and the internet. That means all your data is protected from hackers, your browsing stays private, and your IP address is hidden. You can even change your virtual location by picking from over 3,200 servers in 100 different countries. This will let you watch shows not available in your country, get better deals while shopping, or if you're traveling, you can watch and browse the internet just like you're back at home. Surfshark also offers a plan called Surfshark One, which gives you access to their VPN and a ton of other features like an ad blocker and an antivirus, so you really know you're safe online. I use Surfshark to stay safe online, and you can too by going to surfshark.com/spacechip or use code SPACECHIP at checkout. By using my link, you'll get 4 extra months of Surfshark VPN. And no need to worry, there's a 30-day money-back guarantee. Thank you to Surfshark for sponsoring this video. Let's get back to it. I do want to see really quick, if the planets all didn't get sucked in, what would happen? So here's the same simulation, but I sped up the orbits of all of the planets so that they don't get sucked in. They're orbiting fast enough now. Whoa, okay, I don't know what's happening to Betelgeuse. Okay, it looks like the orbits aren't perfect. Oh, we lost Jupiter. I want to see what is the temperature going to be like. Actually pretty stable. Very, very hot though. At around here, you can see it starts to glow. That is Betelgeuse, which you might think, okay, that is a super big star, but no. There is an even bigger star we're going to try. You may have heard of it, Stephenson 218, which is the largest star we know of. Okay, you see this here, this view? It just looks like a very bright star, right? This is Stephenson 218. Like, where is the solar system? This is it replacing the sun. Like, what are these out here? That's Uranus right here. Neptune here. Is that it? Is that all that's left? That is insane. Oh, wait. Is that Saturn? Yes. Okay. So it looks like it just barely reaches out to the orbit of Saturn. So no rocky planets left. There wasn't any left on Betelgeuse either. But if you could stand on Saturn and look up at the sunny sky, right? That's a sunny sky for sure. For sure. You can see the actual, like, the larger a star is, it's not going to be perfectly round because there's like variations in the gravity on it. And you can see that clearly here. I mean, you wouldn't be able to see anything, let's be honest. You would see this for probably 0.1 seconds and then you'd be dead. But look at this star. This is the largest star we know of. Next to Saturn. Insane how big this star is. Let's see what this does to the solar system in real time. Okay, once again, just look at the shadow of this. This is the solar system, right? We've all seen this. But Stephenson 218? It's like as big as the solar system, dude. That is so crazy. Okay, real time, what happens? I bet we're gonna immediately see heating up on Uranus. It might actually take, because these scales are so big. If you didn't know this, the light from the sun takes about 8 minutes to get to Earth. So it's 8 light minutes away. Like, this distance is 10 AU. So it'd actually take 80 minutes about before anything would happen. Because that's like the closest object. I mean, some of these closer objects would get affected first, but these scales are just so massive that if this random star plopped in here, you actually wouldn't even see it for over an hour. I think we are gonna have to speed up time a bit. As we speed up time, starts heating up, and you can see a hot spot developing. I actually don't think anything is gonna survive this time, not even Sedna. All of the asteroids out here just start glowing. These all melt immediately into lava. And then average temperature on Uranus now. How long has it been? I can't tell. I don't know when the sim started. But over 2,000 degrees as everything gets pulled in. Let's see if anything survives this time. Oh, that's cool. Sedna's gone. No, it's all gone. Stephenson 218 compared to the solar radius, it is over 2,000 times bigger than the sun, but it's only 40 times as massive. So it's just a lot less dense. But it's crazy how big these stars can get. So that is, what if we replace the sun with the largest known star? Very, very crazy things happen. Let me know what you guys want to see replaced in the future. We can go in Space Engine, Universe, Sandbox, maybe replace planets with other planets. Or you know what might be cool? If we made Earth the moon of like a gas giant. Let me know what you guys want to see. Thank you all so much for watching this video. Let me know what you want to see in the future in either of these games. It's a lot of fun making these. I hope you all have a wonderful day. I'll see you all soon. Goodbye.